Let's use an example to further demonstrate the concept of static and also an instance. Let's start with our favorite method, which is the public static void main. As you can see, this countable class right now, it does not have a main method. What if I want to run it? You can see that it says error, main method not found in class countable. The reason is Java Virtual Machine is considered an external object of this to this class countable. In order to run countable as an application, countable must have a static and a publicly available method to be run. And this method, Java Virtual Machine will default to main method. So when you want to run this countable as an application from Java Virtual Machine, you must have a main method. This main method must be static because when you run this method, you don't have any instance of countable yet. You have to use a static specifier to tell Java Virtual Machine that this one can be called without creating any instance. And of course, it has to be public. Otherwise, external object from Java Virtual Machine will not be able to call this countable. So let's say just say system.out.println instance count. So now that I run this application, it gives me 0. Why? Because there's no, because once you start loading this countable, it's initialized to 0, and there's no countable instance yet. Now, if I create a countable C equals to, let's say C1 equals new, not new countable, and I'm printing out this again, this instance count again. I have one instance, right? And I can go on and on and on. Every time I create a countable instance, the instance count, Java Virtual Machine will call the countable constructor, which will add 1 to this instance call, and the print to this instance count. And the print line within main will show us one more instance is added to this instance count. Okay. However, I can create an instance, but I cannot directly call any instance field from static, because from a static method, you will not be able to, there's no instance created yet. You cannot directly call this get instance count. For example, if I try to call get instance count, I will have an error, and it basically says cannot make a static reference to a non-static method. You can only call this method by referencing C1, by referencing an instance, because this method as an instance method belongs to an instance. You cannot directly call it from static method. So now we are going to get the same result, 0 and 1. Okay. However, on the other side, on the other hand, you can see that get instance count is an instance variable, right? It's an instance method, as well as its constructor is an instance constructor, but they are able to call to utilize this instance static method. So although static method cannot access instance field or instance method can use static field or calls a static method. And instance field apparently can access, instance method can access any instance field. Now, we also talked about shadowing. When you try to call a method, you can define within an instance method, you can also define a variable oops, not it, with the same name, for example. There's nothing stopping you from doing that. But now that you see there's a variable, a local variable called instance count, the same name as a static field, what will happen if we call it? We are getting 5. The reason is right now, once you define the local variable with the same name, Java Virtual Machine will find this local variable first. And the static class method, class field is now being hidden because it's already be overshadowed by the local variable. That's why it's called shadowing, because the local variable is shadowing the static class member. For this reason, you should not use the same name as class member. Either it's an instance name, either it's an instance field name or a static field name as a local variable. Now it's getting back to italic, and it's using the static member.